And then, Matt, if you could give me a thumbs up or have your video on just so I know you're ready to go, that'd be awesome. There you go. Sweet, cool. So what we'll do for the big O notation exercise is again, we're kind of just going along. There's different ways of talking about big O notation, but I feel like this is like a pretty solid approach to just get a feel for like how you would identify what your big O notation is, kind of like your worst case scenario, the trend of your function's time complexity as the input grows. So this is solid as far as like being able to communicate with someone in a job interview if they were to have you look at two different functions and say, hey, which one is could you argue for is a better function to write? So we have our unique linear function. And then we have our unique quadratic function. And, I did a little demo earlier of yesterday of how these are both doing the same thing. They both take an array of strings, and the output is they return a new array that just has the unique strings. So if there's matching strings, they don't make it into that final array that gets returned. So they both do the exact same thing. And the question just becomes maybe which one is more better on the time complexity side. So what we'll do is we'll go ahead and we'll have all of us will each kind of like take a line. We don't do as much code reading on the second half of the course, and for this we're not going to do code reading. We're just going to talk about the number of operations and the number of times that they run. So I'll demo a couple lines, and then we'll kind of alternate as we go through here. And let me bump up the size a little bit. So on line 4, we'd say that we have one operation, this object being assigned to the variable string. This one operation and it's happening one time. So we have an O of 1 in this scenario. So that's going to be our constant time. This only happens once, no matter how big the function gets. On line 5, we have one operation, this array being assigned to the variable unique. And how many times does it happen? It only happens one time. Then we get into our for loop. So on line 7, we'd say we have one operation, the 0 being assigned to I. And this happens just one time. No matter how many strings are in our words array, we know that our initial expression in a for loop only happens once. So even if you had a input of an array of 1,000,000 words, we set I to 1, just I to 0. We just do that one time. That one operation happens one time. So you have O of 1. Then in our for loop, we have next on line 8, we have two operations. We're accessing the length property on the words object or the words array. So there's one operation, and then we have another operation with this comparison operator, seeing if I is less than words.length. So there's two operations, and they happen n amount of times. So basically, as your input grows, if there's one word, it happens one time. Or one element, it happens one time. If there's two elements, two times. 200 elements, 200 times. 1,000 elements, 1,000,000 elements, 1,000 or a million times. Now, of course, there could be logic in your for loop that causes it to break, but we don't really pay attention to that. We think through like what is the worst, kind of like the worst case scenario. And that's we're looping all the way to the end of words.length, or we're iterating all the way through that many times. So we call that n. That this runs as the number of inputs grows. So 2 times n, that gives us that we always leave the O in front. That gives us a big O notation of O of 2n. And then kind of like we weren't learned through reading through the documentation, and hopefully you got to check out Brett's video and also the one I recommended by Colt Steele. I feel like that was really good. We don't really pay attention to this coefficient. We're looking at the trend of the function. And the trend is that it's going to run, this line of code is going to run n amount of times. We're not worried about the two. I suppose in some scenarios, super intensive data scenarios, like those coefficients like could matter, but as we're talking about like the code that we're writing and we're evaluating, we drop the coefficients when we talk about the big O notation. Then on line 9, this one's a little bit trickier and could be easy like not to catch. When we increment I by 1, we're doing two operations. we're adding the value of 1 to I, and we're reassigning it to I. So this is actually I equals I plus 1, right? So here's one operation, and then we have the assignment operator, two operations. And this happens n times. As the number of inputs grows, this for loop runs, and this final expression runs each time. So that's 2 times n. So O of 2n, we drop the coefficient 2, and this line of code, the big O notation for this line of code is O of n. So that's a little bit of a demo of a few of those. The main thing that when it's your turn to read, or when it's your turn to describe it, is I just want you to hear you say like, okay, the number of operations and how many times it runs, and then touch on the if there's coefficients, what is the big O with the coefficient, and then what is the big O without the coefficient in there. So Ahmed, I'll throw you on the spot for line 11.
All right, you might have to help me out a little bit with this one.
Yeah.
Uh, so we have words at index I
That's
being
one.
being uh, and then do I mention the number of operations here or
Yeah,
continue
you
with
could
the code?
say that's one operation.
Okay.
hmm
So that's one operation, and that's being assigned to the variable word, and that's a second operation,
Yep. Awesome.
uh, and that has a time complexity of or a big O complexity of O of 2n,
hmm hmm And then
and
when
then
we drop the coefficient, we'd say it's O of n as
and
far
then
as
okay.
complexity goes. Yeah. And then
Just
you might have,
because like
oh, sorry,
sorry.
go ahead.
So basically O of 2n and O of n are basically the same, like the coefficient is irrelevant, you mentioned, right?
Yeah, we're basically saying that we don't care about the coefficient. We're just looking at the trend, that this line of code is going to run essentially as the number of inputs grows, this line of code is going to run. So that's when we're kind of like reducing it to the most basic form of describing the big O notation. We just say O of n. More precisely, it's O of 2n, but we could rightly in an interview just describe it as O of n. Sweet. Han, do you want to take line 12?
The first operator is the array, seeing the word, and
hmm
the second one is not,
Yep.
and so we have coefficient of two, and since because it's in the for loop and it's a n,
hmm
so that's um, O of n. Sorry, I forgot how to say it.
No. That's awesome. Yeah, no, I think you did good. Trey, line 13.
So on line 13, we have um, seen ray at the word index is equal to true. So that's going to be two operations
hmm
um, at run n times.
hmm
So it's going to have a coefficient of 2n, which will reduce to the 0 of n for the
Yeah,
big O
yeah,
notation.
yeah, big O event. Awesome. And I'll do the next one. Um, we have three operations here. We have we'll talk about this that we're getting the length property of unique, so that's one operation, and then the index of unique, um, and then also the assignment operator of word to this index. And then so that's three operations. It happens n times because it's in a for loop. So as the amount of inputs grows, this line of code is going to run. And so it's a O of 3n. We don't care about the coefficient 3, so it's O of n. Awesome. Then I'll take this one. Line 17, we return unique. So it's one operation. It only happens one time. If there's 5 billion inputs, ultimately this line of code just runs one time. So it's O of 1, that constant time. And so when we think of like the big O notation for the function, um, we can't just look at line 17 and say like, oh, that's constant time, and lines 4 and 5 are constant time, so that's like pretty snappy. You have to count for if there's a million inputs, this for loop is going to run a million times. And so that means we need to look for, what is the worst case scenario? It's that O of n. So our big O notation for unique linear is O of n. Any thoughts or questions on that one? Sweet. Cool. All right, our next one is unique quadratic, and so the name gives it away that this is going to be a quadratic time. And the tip is that if you ever have a for loop inside of a for loop, you're dealing with a quadratic equation. And so just to illustrate like why that can be so slow, um, function quadratic. If we have two for loops, let's say for let I equal 0, I is less than 10, I plus plus. So I'm going to say console log, can't type right now. Put a string outer loop I. And so then inside this for loop, we're going to loop again. For let j equal 0 as long as j is less than 10, j plus plus, console.log inner loop. Let's see if I didn't forget anything. So now when we call this, we can see that the outer loop runs once, then the inner loop runs basically 10 times. We start at 0, so it runs 10 times. Then we do the next outer loop of 1, then the inner loop of 10, then the outer loop of 2, then the inner loop of 10. So we can see pretty quickly how when you stuff a loop inside of a loop, how often it runs. And that's a little bit of an exaggerated contrived example of when they're each running 10 times. You can see how much more extra work that inner loop is having to do. And so you can imagine in a large enough application, when you're working with data, that can slow you down a bit, or it can slow down the time complexity or increase the time complexity. So let's go ahead and we'll move through here. So I'll just do this first line really quick, just as a reminder. We've got one operation of the array being assigned a unique. It happens one time for a big O notation of O of 1. So Ahmed, if you want to take line 23.
So there's one operation of 0 being assigned to I. So it's one operation that's happening one time, and it has a big O complexity of O of 1.
Yeah, awesome. Han, line 24.
Um, so there's words.length that dot is one operation, and there's a not bigger than the second operation,
Yep.
and also because it is in a for loop, so um, so it's n times,
Mhm.
so the O of 2n and approximately is O of n.
Yeah, awesome. Well done. And then Trey, line 25.
On line 25, we have I being incremented twice, so that's two operations for n number of times, which is the coefficient of 2n, which reduces to the big O complexity of O n times.
Yeah, yeah, and you might have just been a slip of the tongue. I think you said I incremented twice, but it's incremented once. It's just two operations.
Sorry.
It's the adding the one to I and then assigning I plus one to I. So we got the two operations there. Awesome. Um, Sweet. Let's go to the next one. I'll take this. We're still in our for loop. So we got words at I. So we got the index of words. That's one operation. And then we are assigning that to word. So it's two operations. It happens n times because it's in our for loop. So O of 2n with the coefficient which is approximately O of n as far as big O notation goes. And then let's go with Ahmed, line 29.
We have the Boolean true being assigned to the variable is unique. That's one operation, and it's happening n times because we're in a for loop, which gives it a big O notation of O of n.
Cool, awesome. Then Han, line 31. Oh, you muted.
We have a sign operation, and so one operation and inside of for loop, because it's just a sign, so it's n, um, and so it's O of n.
Yeah, awesome. And the one thing that's a little bit different about this one is that this initial expression is actually going to, because earlier when we looked at an initial expression, it was constant time because this only fires once for the outer for loop. But because this inner for loop, actually I could have pointed this out here, the outer for loop, the initial expression just runs once, no matter how many inputs. But the inner for loop right here is going to, that initialization is going to happen every time after we do like a round or one iteration in this outer for loop. So it's a little bit unique in that this will happen n times rather than just one time, as in constant time. So, and then the next line, tray, so that we're inside of our inner for loop.
So we have C is greater than I,
Mhm.
and that's going to occur one time, but it's going to be iterated over twice because it's the inner loop. So it'll be the big O to n squared.
Yeah, awesome. So we got our quadratic time. Now take this line. We got C being incremented. So that's an addition operation and it's a reassignment operation. So we got two. It's inside of a for loop, so it's n squared. So our big O is O of n squared. I think we didn't show like the coefficient one in the teacher solution. Could probably have that in there, but ultimately it's approximately O of n squared. Next, we'll go ahead. So inside of our inner for loop, line 35, Ahmed.
We have words at C.
Mhm.
That's one operation, and that's being assigned to the variable comparing. So that's two operations, and then is it happening n squared times?
Yeah. Yep.
Okay, so it's happening n squared times, and because we're inside a nested for loop, uh, it gives it a time complexity of O of 2 times n squared, which reduces to O of n squared.
Yeah. Awesome. Cool. And then we'll go with let's see that always gets bumped down here. On line 36.
So we have a comparing strict equal to word one operation,
Hmm.
and it's a for loop inside for loop, so we got a n square, so it's O of n square.
Yeah, great. And then Trey, line 37.
So on line 37, we have false being assigned to is unique, and that's only one operation, but it occurs n squared times. So it'll be big O to the n squared.
Yeah, awesome. Well done. And then line 40, we have one operation. We're checking if is unique is truthy. And that is happening n times. So this is no longer inside of that inner for loop. And it is going to be O of n as far as big O complexity. And then Ahmed, line 41.
So we have a word being assigned to uh, unique at unique.length.
Hmm.
So that's a total of, is it three operations or is it two? since
Yeah, it's
we're
going to be
looking at two
three
n.
because we have one operation here to get a value for the length of unique, and then we are accessing that index of unique, and then word is being assigned to that. So
Okay.
three operations.
So that's three operations, and it's happening n times, which gives it a time complexity of O. Would it be 2n?
Yeah, so O of 2n. Oh, I'm sorry. That
3n, I'm guessing.
3n. Yeah.
Okay. Yeah, O of 3n, which reduces to just O of n.
Yeah, awesome. Then last line, line 44, with Han.
Um, it is a return statement, which is outside of all for loop, so it's just linear time, O of 1.
Cool. Awesome. And then yeah, so when someone says, what is the big O notation for this exercise? You're not going to look at the constant time here. You're not going to even look at the linear time here of O and N, because you could wind up in a situation where you will wind up in the situation where you are going to have, if you have 1,000 inputs or 1,000,000 inputs, and you've got this inner for loop running, this is going to be the log jam. So we would describe the big O notation as O of n squared, or quadratic uh, equation, or quadratic time. So in general, if you are writing a function with a for loop inside of a for loop, that's a good time to think through, how can I refactor this uh, in your final project. So that could be reaching out to me, that could be ChatGPT. I have this for loop inside of a for loop. How do I, improve my, big O notation, or my big O time complexity, and get some feedback there and how to simplify that. But ultimately, like, if you do have a for loop inside a for loop, it's not the end of the world, but it's something that, like, if you were in a conversation with someone in an interview and they brought that up, you'd want to be able to talk about, like, oh yeah, I understand, on this line, this is why the time complexity is, quadratic time, because it's a loop inside of a loop. So being able to convey that about your code would be important in a conversation, even if it's code that you did have to ultimately stick with and write. Um, Sweet. I actually really like this way of talking about big O notation, of identifying it. When I went through a coding boot camp, there's a lot of big words thrown around, and ultimately at the end of it, like, I could regurgitate some of those big words, but I didn't know how to identify where my function determines what the big O notation for a function is, and how to compare them to each other. So, any thoughts or anything on big O notation before we move on? Sweet. Well, there's no quiz questions for this exercise. So let's circle back to the calendar, um, and talk about what's coming up. This is my absolute favorite part of the course, for sort of an odd reason. And one thing to note is I did pass out these data structures, DS list, BST, binary search trees, and hash tables, where you're creating these data structures from scratch. Um, I tend to take an executive decision. I've taught the senior side about 4 or 5 times now, that, like, I decided to make those optional, just because they are very intense in difficulty, and the payoff as we go towards building our actual, like, final project isn't quite there for me. And it's usually something that our students don't get interviewed on in their jobs. Um, Robert will talk about, we do senior lectures during the final 2 weeks of the program, and he'll do a lecture on data structures and why some companies will use them as part of the interview process. So it is something that, like, if you're applying to, like, some sort of, like, Google engineer position, or something like that at a certain sort of company, um, focusing on data structures can be worth it. In general, for most of our students, it's not. So I like to leave that as optional. It's something that if you do go through it, like, on your time or whatever, and you want to reach out to me, like, I'm happy to chat back and forth. It could be something that once we get into our full stack project, you need a mental break from what you're doing, and so you return to work on those. Um, Totally fine to do. Oftentimes I feel like post-program, they're a good like option for you to dive into if that's an area of interest. So that's why I kind of put them on the back burner. So that allows us to dive into databases and backend code. And for me, the reason why the next 10 days or so, everything from Postgres that we're going to jump into today to Express CRUD is the most fun for me is because my experience is as a front end engineer professionally. And so as a front end engineer, oftentimes you work with APIs, right? We all saw that with your front end project. You're hitting a third party API, getting data. So you have to understand like what is at that endpoint, what's the structure of the data. So that's a real front end reality is understanding APIs, but I never got to like obviously like build any or anything like that. So it's always fun for me as I've taught through the senior side four or five times or so to go through this because I'm literally always learning something as we're going through this. So it's sort of fun for me. So I won't carry myself as like the expert in regards to some of your questions that do come up, just because I want to be upfront about that. That sometimes I'll say like my hunch or my pretty strong feeling is that this is why we would take this approach. Um, Sometimes we have time and space available to go down like a rabbit trail, with certain questions. And if we have the time and space to do that, we can definitely do that, open some docs, check some things out. However, for me, like my eye is kind of always on, the calendar and the amount of things we gotta get through and kind of like being efficient. So there's gonna be times where you might ask like an excellent, great question, and I'll just say like, hey, I think we might need to punt on that. We can all do like some individual research, and if if someone comes up with like an insight on that, like we can definitely discuss later. But I'll be kind of playing time clock management because there is a good amount of chunk that we want to get through to get into our final project. And so as we are covering Postgres, databases and backend and writing your server endpoints and whatnot, these are all deep wells that you could spend, probably, a week on any specific subject. And so just like everything else in the program, we move pretty lightning fast. But I will say that everything that we do cover in regards to Postgres and kind of like our backend endpoints and whatnot, everything we do cover will be everything that you'll need for your final project. So it will be enough. Even though it's tip of the iceberg, it's going to get you to where you need to be and also give you like a foundation for just like everything else. When you want to dig deeper, you actually have like a context and a framework to think about these things. So we'll go ahead and then after that, just big while we're here looking at the calendar, if you're the type of person that's curious, we're gonna do some database stuff today. What is Postgres essentially? Like usually our students don't go on to be database, developers. We tend to be front end or back end, but we'll talk about what is Postgres for a bit. In our final project, we help you all get like structured with like setting up your Postgres like schema and what tables and how you want to organize your data. But then we jump into the SQL query language, and just like you probably talked about on the front end side of your course, your apps typically have CRUD functionality where you can create, read, update, and delete. So Code Journal, you could create an entry, you could read an entry in your entries list, you can update an entry, and you could delete an entry. And so that's going to translate to basically the back end too. We're going to learn how to use SQL to do CRUD operations on a database. So SQL select is how to read from a database. SQL mutations is where we're going to see how we can create an entry in a database, update an entry in a database, and delete an entry in a database. And then we're going to find that in SQL, oftentimes you're going to need data from two different tables that are joined together by a key. And so we're going to learn how to get data from two tables, three tables, sometimes four tables, and we're going to see the complexity of that. So hopefully that'll help you as you see how complex it can be to join multiple tables. It'll help you on your final project to determine like what is my schema going to look like? Because if I create too many tables, that could be a real challenge to access that data. SQL aggregates is going to be basically SQL functions where we can count the number of rows in a table, get the average value of a certain column, the highest value or the lowest value, things like that. And then we'll jump into writing backend code. So I won't give too much more of a summary on backend code. What I just gave is enough for the next 2 days we're going to cover. So after we finish all the backend code and endpoints, then we're going to jump back into React, and we're going to basically see how we can connect React to hit our server endpoints that we've created, and how those server endpoints are going to query our database and get data. And we're gonna end up with creating, basically, when we get to full stack practice, of how to basically create a whole full stack project. And you'll see like the full scope of what you would build for your senior project. So it'll have you like in a good spot going into the final 3 weeks of you'll have an idea of what to build, because along the way you'll have seen what a full stack app looks like and how it operates. So Postgres intro, or actually any thoughts or questions on the calendar? I know I just breezed through a lot. Sweet. Well, Postgres intro is where we're going to start first. And one note, just like on my schedule today, is I do have a previous student with some deployment issues. So I'm supposed to jump into a breakout room with him for a chunk of time and work through deployment issues. But it sounds like his power is out, so it might not be the distraction I thought it was going to be. So I released a couple exercises this morning just so you guys could keep on working. So there may be a hiccup in my schedule where I'm not available for a bit. And if that's the case, then I'll mention in a second how we have extra exercises that you can kind of move into. Postgres intro is introducing the Postgres relational database management system. So this exercise mainly is a heavy reading exercise where these big new words will hopefully start to make some sense. Like, what are they? Like, what is PostgreSQL, first of all? What is a relational database management system? Like, well, what's that? So you'll have quiz questions to go through. PostgreSQL, if we're talking about pronunciation, whenever you see this right here, we would say PostgreSQL, or just Postgres is fine. Or just calling it your database in our conversations, that's fine as well. There's a conversation on like why databases. You could store data just like in a file. Like why does it make sense to have a database to organize and access your data? What is PostgreSQL? There's a lot of SQL databases, and what makes something an SQL database is because you can use the SQL query language to query data from that kind of database management system. So there's a number of different ones out there. The nice thing is that because they all basically operate with the SQL query language, is that once you learn one, you basically have them all down. There's going to be like some slightly different syntax that you'll see here or there, but if you know the SQL query language, then you can access and interact and do CRUD functionality with all of these SQL database management systems. So what's a relational database? There's some conversation on that versus a non-relational. If you've heard of like MongoDB, that's a non-relational. There's conversations of the pros and cons, like what relational databases are good for, when you might start to reach your limitations with them, and why some people reach for other type of database management systems. And then the resources sections, just to highlight really quick. You want to check out this quick little link, just like a minute or so of reading. Nothing big there. There is a link to this database guide that I just saw as broken. So these are just a number of your PostgreSQL commands. So the way that you get there is that this output looks here. Let me sign in as a student. If you go to guides and database, PostgreSQL commands, you'll want to save this. Like I have it saved up here for easy access. Because just like when you're going through React and it's like spin up a new React app and that command is no longer there and you had to go back to a previous exercise to find it. As we're going through Postgres side of things, database side of things, there's going to be commands to say start your Postgres service, and we're not going to have the command for you, or stop your service, and you're not going to have the command for you. So having all of that in a guide will serve you well. So again, that's just in the guides and database drop down Postgres commands, QL commands. You want to have that saved somewhere for easy access. So again, this link is broken. So when you get there, it's broken. I'm aware of it. We'll have to do a PR for it. Um, in this exercise and some others, there's going to be some operators in Bash that we're going to use, just like in the terminal. So this is a little link that kind of gives you an explanation of what those operators are. I'd say you could spend like 30 seconds breezing through it. Mainly, it's going to come into play for step 8 of our exercise, where you're going to do this Postgres command to get a list of your databases. That's what's over here on the left-hand side. And then this greater than arrow is that bash operator that takes whatever input is on the left, the result of it, and it outputs it to this file. And so that's a bash operator. So that's what that little bit of documentation you might take a look at is. So this exercise, one thing it's going to ask you to do, and isn't always obvious how to do that, is when you are in Postgres intro, there's going to be one point where it asks you to have 2 terminals open at the same time. You've probably done that before. In case you haven't, you have this pane right here where it shows like 2 windows. If you hover over it, it's a split terminal. You'll just click on that. And that's how you can get another terminal in the same directory. You can hit it again and again and open a bunch of them, but you just need to have 2 of them open for this exercise. So you'll be asked to do that. And that's the little icon that you can click to make that happen. The rest of the exercise itself is really just a step through. You're just running some commands, and then ultimately at the end, you'll be printing something to a new file using the bash command. So the exercise itself takes about 25 seconds. It's pretty fast. So the majority of this is doing the reading and the quiz questions, and then stepping through the directions. So take your time, don't rush. I'll give us say like a half hour to do this, so you can kind of pace yourself as far as how to go. If you get things submitted quickly, I would still go back and I would read through this documentation 5 times. Take notes as you read through it just to help it kind of like sink in as you go through. And then we'll regather at 10:10. Like I said, if I have that student who I got to do the deployment issue with, then I'll have to hop into that breakout room with him. And then I'll just, in that case, we have already released the next exercise, Postgres database. So you can jump into that, but I'll let us know if that becomes the issue. So with that said, dive in, and the tentative plan is that we'll return at 10:10 to do a Q&A. So we'll see you all in a bit. All right, we'll give another second for cameras to go on. And cool. All right. So where we are at with Postgres intro is we'll do a quick walkthrough of the exercise, and then we'll chat about the quiz questions. If there are still a work in progress on the quiz questions, that's fine. You can give it your best shot or pass it if you don't know. Yeah. And then I'll make sure maybe we jumped the gun with having this Q&A just a tad too early. So I'll maybe slow down the pacing a little bit more just to make sure that we all can get our majority of our PRs in. So this exercise, we're just again, we're just kind of like walking through working with Postgres and our database. So we're getting started with some commands. And remember, Postgres is already installed in our dev environment. For step one, we want to make sure that we have two terminals open and we're executing the top command in one of them. And this is going to show us our currently running processes. And we're going to see that Postgres is not one of those processes. So now in step two, we're just going to start our Postgres server. And then when we do that, we're going to see Postgres is now popping up on the right-hand side. So that's the point of this is really just to show that Postgres is running. You can use the top command to see what's running and what's not. This isn't something that you need to remember as part of your repertoire, but it could be something that maybe if you thought Postgres was running, you could type in top and get verification to see if it's running. The alternative, I close this, we don't really need that panel anymore. The alternative is to run this command Postgres status. So I'm skipping step 4. I'm aware of that. And we can see that it's down. Postgres is not running. So step 4 told us actually before that, before we check our status, to start up our service again. So we'll go ahead and do that. And now after we've done that, we'll see that when we run sudo service Postgres status, that we're going to see that we're online. So instead of down, we're online. You can quit top by pressing Q if you haven't already done that. I just closed that terminal. So you could have taken either approach. So now in either terminal, let me just open that up just because that language keeps on coming up. In either terminal, we can execute the PSQL command to list the databases in your Postgres database server. So this is going to give us a list of your databases that you have available. So you got dev, Postgres, and dev Postgres template 0, template 1. This doesn't mean a whole lot right now. That's fine if it doesn't. One thing, and I shall demo this in a second. The last step in this exercise is going to be to print that list of databases. So let me run this command again. So we're going to print this. So this is that same command that's going to get this data that we see in the terminal. And we're going to use this bash command to print it to a new file. If the file already existed, we would override it with this new content of what's on the left. If the file doesn't exist, then the file will be created. So we can see that that file does not currently exist. So we'll run this command. And it didn't exist yet, so it was created. And if we look at it, this is the same content that was in our terminal. So we took the result of this Postgres command that was outputted here, and we just used the bash command to put it in a file. You're probably not going to do this too often in real life, but now we have our listed databases right there. Now, one thing is this isn't super easy to read through, right? So there's a tool that we're going to see in our next exercise called PG Web that comes installed in our dev environment. It's for visualizing our database. And I'll just go ahead and run it here. PG Web. PG Web. And so as long as you got PSQL is running, as long as you've started it. This is going to give you a GUI that you can look at in the browser at localhost 8081. And you have like a visual representation of the browser that's quite a bit easier to read. So next exercise, we'll talk about this a bit, but in the upper left-hand corner, you can click on, and these are different databases next to this icon. So there's Dev and Postgres. And I think template 0 and template 1 that get printed out, those aren't really like viewable, so that they don't show up, if you're wondering why they're not there. So in the next exercise, we're going to get more hands-on experience with that. So this one, not a whole lot to do other than kind of like step through starting up your database instance, closing your database instance, checking the status of your database instance, logging out your databases that are part of your Postgres environment. So let's jump up into the quiz questions. And so these will definitely be fleshing these out over the coming exercises. So Ahmed, why do we use databases in web development?
I actually didn't quite get to the quiz questions. I was still kind of following the exercise and going through the reading. So
Sure. Yeah. Trey, do you want to give it a shot?
Yeah, sure. I said to store, organize, and manage complex data that can be easily accessed and quickly retrieved.
Yeah. It's for our apps, we want our data to persist, versus like using like local storage that doesn't really persist across different, computers. Oftentimes with like user management, having those in your database to handle like logins and logouts, authentication. The next one, well, we'll go ahead and make this the Trey show. Um, Trey, what is PostgreSQL and what are some alternative relational databases?
So it's an open source relational database. It's object relational or relational, sorry. And then some alternatives would be like my MySQL, Oracle, and then SQL Server by Microsoft.
Yeah. I think SQLite comes with a lot of startup code for a number of different like projects as well. What are some advantages of relational database? I'll take this one. Some advantages of learning a relational database is just that because they are so, one of them is obviously for the benefits of like your application and data persisting and whatnot. But and in the job industry, relational databases are pretty huge. And if you learn one, the SQL querying language, then that's going to translate over to a number of other ones. So it's kind of just, there's a good chance you will interact with it professionally. And then Trey, what's one way to see if Postgres is running?
I said to use the command in the terminal, the sudo service PostgreSQL status.
Yeah, awesome. Sweet. Yeah, this one is a real skeleton type exercise, so there's not a whole lot of meat on it. But any questions about this? Any follow-up questions? Cool. The next exercise we're going to get into, Postgres database has a little bit more substance to it. So let's get in the right spot there. Postgres database. In this exercise, we're actually going to create a database in the system. You're not going to create the tables, the schema of tables, what the rows and the attributes should be. Those are going to be populated for you, but you will create a database in the system, and then we're going to do some imports to actually fill in the tables in your schema. So Postgres database is creating a database with PostgreSQL database server. Relational databases store data in relations. The name kind of defines itself. These are commonly referred to as tables. So what are tables? They're relational databases that store data in relations. So a table is going to be a list of rows. So and each row is going to have the same columns or attributes. So columns and attributes, those names are going to be used interchangeably. So, for instance, you might have a student table. It's going to be full of all these rows, and each row might have like an ID, a first name, a last name, a something else that you might want to store in a student table. Um, when you have multiple tables, because you might have, a student's table, you might have a teacher's table, you might have maybe, a grades or a school table. When you have multiple tables, that's called a schema, is the tables that belong to a database. So you're going to get some of that terminology as you do reading. There's a section on database visualization, and that's just what I did, PG Web. And then if you do PG Web, that's going to open up just by default to the dev database. But if you were to, so here's another one. Hang on a second. Oh, I killed the database. That's why I wasn't. Let me start up a database really quick, just for the sake of illustration. So if you type in PG Web, you're going to open up to dev by default, and you can click on here and see what other databases there are and transitions to those. The alternative is that you could do PG Web dash DB, the DB flag, then name the database you want to open. Postgress. So let me close this. So now when we go to localhost 8081, and it opens up directly to Postgres. So that's all that flag does for you. So I highly encourage you as you are doing this to do the database visualization step right there. There's some resources for creating a database. I'd say you probably would just read through just like the first small section there. You don't have to go far into that at all. In this exercise, you're gonna make sure that Postgres is running. So like I've already done that. And then you can take a look at what databases that are there by running this command that we did in the previous exercise. That's going to print them out in the terminal. You can also, I would probably just go to PG Web. That's what I would do. Then you're going to create a database with this command. And then one of the steps is going to be to print out those databases, and that's so that you can see that it was created. So that'll populate this list of databases.txt file. You can also look in PG Web and see that the database Pagilla exists. And then what you're going to do is you're going to populate that database that you just created. And at this point in time, in the final project, you're going to come up with the schema, the tables, the seed data. We're not expecting you to be there yet at all. And we're going to start off with this two files. You're going to see a schema.sql. And you're not expected to understand this at all. But this is going to create a number of different tables. So your schema is a collection of tables. So this is what's going to create a bunch of tables for you. I think it's like 10 or 15 or something like that. And then you're going to have a data.sql file. And this is what is going to seed all of those tables with their appropriate rows for whatever the table is about, whether it's cities or zip codes or movie rentals or whatnot. And if you look, oops, let me see. You can drag this down and see that this data.sql file is like 45,000 lines. So it's huge. So you can take a quick glance at both of these. What's your schema. You're not expected to really like understand or have a deep grasp of it. And you can take a look at like what some of the seed data is. But ultimately, you're going to run these two commands, and that's going to import in your schema. into your Pagilla database, and then you're going to run this command, and that's going to import your seed data for each of these tables. And then you're going to have some more terminal commands to like spit out that data. And I would encourage you after you do that, look at it in PG Web. I think it's a little bit more helpful, but you do want to follow this step just for the sake of submission. And then finally, you're going to do one query, a select query. Our whole next exercise will be about selecting, which is like the read functionality of CRUD. So you'll do a quick little query to get some data, and you'll replace, table name with an actual table that exists. And then you'll follow up with answering any quiz questions that are there. So yeah, that's the task at hand. We're gonna jump into break right now. Trey, you and I can jump into a breakout room, and then so grab a break, put a bow in the Postgres intro exercise as soon as possible. Let's jump on this. It'd be great to get a Q&A done before lunch, but also we might just do it after lunch as well. We'll just see when those do come in. So yeah, Trey, let's jump into a room and we'll work through that issue. All right, hey, let's go ahead and gather back, and we'll do a quick walk through of Postgres database. Again, it still feels like a little bit of a skeleton episode, as we're kind of just skeleton exercise, not episode, as we're just getting our database stuff set up, and we'll move into more meatier exercises with querying our databases and doing our CRUD operations and whatnot. So yeah, I'll go ahead and step through here through the exercise. And if you have like any steps or anything as I'm going through that you want me to elaborate, definitely feel free to raise a hand and I'll be happy to elaborate. So the first thing we want to do for step one is make sure PostgreSQL is running. So make sure that I got my cheat sheet right here. So we start it, sudo service PostgreSQL start, and it looks like it's running. Next, we want to make a mental note of the databases in your PostgreSQL server by running this command. So we can see this is what we'd expect to have, Postgres template 0, and I think there's a template 1 in there as well. At this time, wouldn't necessarily be a bad idea to have another window open and get PG Web going. It's a bit more friendly than running this command. So localhost 8081, and we can see that these are different databases that we got up and running. Next thing we want to do is we want to create our create a database. And so we do that with this create DB command. So create DB Pagilla. So no errors there. Now I can go ahead and look here, and there's Pagilla. So Pagilla does exist. This over here. And just to kind of demonstrate again what I might do, since we're going to be working the Pagilla database for a while, is when running PG Web, then the --db flag, Pagilla. Now when I open up localhost, so I'm going to close this. If I was to open up localhost 8081, it opens straight up to Pagilla. So I think that'll get used to using that flag. It'll just save you from always having to switch to the database you eventually want to go to if you know it off the top of your head. The next thing we want to do is just for this exercise's reasons. There's no like logic of how a program would run that you would necessarily need to do this, but we're going to take those databases that we saw in the terminal and we're going to print them out to a file called listofdatabases.txt. And there it is right there. We see that Pagilla database we created. So briefly skim through the data.sql, schema.sql. I kind of gave a quick glance at that during our time together, so we won't necessarily do that again. Hopefully you got to spend some time in there as well. It's okay if it felt odd or mysterious. That's completely fine at this point. Just note that one of them is your schema, and that has basically your tables and what makes up your tables, what attributes they have, how they're connected. And then the next one is data.sql, and that is just all your kind of starter data that's going to get shoved into the tables. So we want to go ahead and if we were to look at PG Web and we were to look at Pagilla, there's no tables, there's nothing in there at this point. So that's what we want to activate. So first we're going to bring in our schema. All right. And I think, yeah, so that we brought in our schema, which is just our arrangement of tables. And so we can see all of them. And if I open this up, oh, interesting. I would have thought in PG Web that it would show you like the column titles, but I guess with no records in there, it doesn't show them to you. That's odd. I think that would be there regardless of having entries or not. Because our schema is where we like to find what our attributes slash columns slash fields are for each of the rows. So now we'll go ahead and bring in all that seed data of like 44,000 lines. And computers are so fast, it's already done. And so now if we do a refresh, we'll see that these are all now populated with data. And at that point with the seed data, you can see actually what the column names are. So again, columns, fields, attributes, all used interchangeably for these column titles or these entities. Cool. So now just for the sake of this exercise, and again, this isn't something that's a real program logic that you would ever really need to do. But we print out the list of relations. So here's your table names under name, just your schema. These are marked public, type table, owner dev. Not much you need to read into or understand about that. So you should have saw the 15 tables listed. So we saw that in that TXT file. We saw it in PG Web. And so we can just get one quick round of practice with using the select command. So again, thinking CRUD functionality, the select command is the read of CRUD, where you can read data. So we can do that by typing in PSQL -d, name our table, and then this is our actual, in the quotes is our SQL query. So select, the asterisk means all, so all the attributes, all the columns from table name from, and we'll grab actors. And we'll hit enter and we get all of the results. So that asterisk refers to column names. So it doesn't just mean like all the rows, it means get all of the column names. We could have specified just getting the actor ID. So we got to put that in quotes. Let me think. I never do this in the terminal for good reason. I always do it within the file because I don't want to embarrass myself. Actor ID has a column called actor ID. I wonder why that doesn't work. I wonder if maybe that's not possible to do in the terminal. Anyways, we're not going to dwell on that. In our next exercise, we'll see how when you're within a file, how you grab a column. Although I'm really perplexed why I can just do an asterisk there and not do a column. So there's probably just something missing in my understanding. Possibly if I did like single quotes, but it's not worth investing too much time into that when we'll see the correct syntax way in the next exercise. So that's it for all of the steps. In any questions about those steps that we just walked through? Sweet. Well then, I've got a set of questions. We'll go with Ahmed. What is a database schema?
I said it's a collection of tables that defines how data in a relational database should be organized.
Yeah, awesome. Love it. And then Trey, what is a table?
It's a list of rows, each having the same set of attributes. So basically, it's the structured collection of related data organized in rows and columns.
Cool. Then Ahmed, what is a row?
An arrangement of data that holds attributes for specific items within a table.
Yeah, awesome. And then Trey, last one. What is an attribute and what other names are used to describe them?
So the other name is a column, and it represents a certain property or characteristic that helps define or identify and categorize each related row.
Cool. Yeah, yeah. Yeah, attribute, um, column, and then also field is a word you'll see slipped in there as well. Yeah, that's all we got for this exercise, and really this just sets us up for what we're about to do with implementing CRUD functionality to interact with a database of information. So, any last second questions before we move on to taking a look at the SQL select exercise? All right, well, let me bring up SQL select and the starter code. As you can see, there's not anything in there. SQL select is just basically how do you make queries to read data from a database. So there's some information on structured query language. So we're going to use that SQL all the time. That's what makes if you're talking about Postgres, MySQL, SQLite, what makes those relational databases? One of the common denominators is that you use the structured query language to interact with them. So there's some information there that you can take a look at. And then what you'll see is little chunks of documentation. So we can imagine you've got this table right here that I'm mousing over. It's got these attributes, columns, fields, product ID, name, description, price, and category. And these different rows or records is another word we can use interchangeably with rows. And so here's an example right here. So here's an example select statement that gets the name and the price. So instead of that asterisk that gets everything, we can just choose the columns that we want. We just want name and we just want price. So we say select and then double quotes name, comma, double quotes price. And then we use the from keyword. And the result is going to be this output, this table here that has a name and price attribute, column, field, etc. And then the matching row or record data that goes with those. So there's just more information on the select statement, the from keyword, etc. There's the note that your query should end in a semicolon. There's a number of things that you can get away with not doing. I think even though it says it must end in a semicolon, I'm almost positive we can get away with not doing that. Good practices, you should have that, and some environments it will force you to do that. So stick with best practices. There's notes that select and from, while they're keywords, they're not case sensitive. So you could do lowercase, uppercase with them. Generally, whatever team you're on is going to have a preference. Like we do all uppercase or we do all lowercase. So teams will decide something like that. SQL doesn't care. Indentation, SQL does not care about indentation. essentially you want to be consistent with what you do. When you wind up on a team, that team will have like some sort of style guide and they'll say like this is how we do this because they want when people are reading through code to have easy eye recognition of when I see indentation, it means this even before I start to read the code. So those are usually just considered style guides that the computer is like fine with whatever, but your team will have like human readable preferences. So here's another example of more documentation where select instead of naming the column, we do this asterisk, and that's going to get all of the columns from products. So product ID, name, description, price, category. I got them all. If you want to sort your data, like maybe you want to sort your data from highest to lowest, um, select asterisk from products, order by price. And so the output is going to be in ascending order, 10, 20, 30. There's a descending flag that you can put at the end, DSC. And you might have to just Google documentation for that. So if you wanted it to be like 30, 20, 10, before the semicolon, you do DESC, and that would spit them out in the opposite order. You can filter. So, you're getting these columns, product ID, name, price from products, but you want to filter some things out. You only want to get results where the category, so that would be one of the columns or attributes, is equal to cleaning. And this is something that you'll need to keep an eye on, is that when you're getting values from the tables, those are going to need to be single quotes. If you did double quotes, then that is going to think you're looking for a column or a table. So this isn't like strings in JavaScript where you can do like single or double quotes, as long as you're consistent. Double quotes means something and single quotes means something. And so you're going to make some mistakes and that's fine. You'll see in the terminal that'll let you know if in the terminal it says such and such is not, a column or a table, that'll give you the idea of like, oh, okay, I must have put double quotes around maybe an actual value. And so I need to change that to single quotes. And then I won't go further, and there's only one more example there. For the actual exercise, you're going to make sure that Postgres has started. And I'm just going to walk through just one of these. And then we have a number of different queries that we want to do. So what we're going to do is we're going to create a file for each one of them. So the first one is actornames.sql. So I'm going to create a file, actornames.sql. And then what are we supposed to do in actornames.sql? We're supposed to get actor ID, first name, and last name from all actors. Because these are in gray, we know that these are actually column fields, so you can trust that. Actors, I would think maybe we could put that in gray so that you can know that that actually is a table that exists, but you'd probably just confirm that. Go to actors, and you would see that there is an actor ID, first name, last name updated. So that matches up with what we saw. So now you write the query. Select actor ID, and these are comma separated. First name, last name, oops. And then after the last one, you don't put a comma. So that's a little syntax error that'll probably catch you. What are we getting them from? We're getting them from actors. And I'll finish with a semicolon. I'll save this file. And then to run the code, we see this command right here. PSQL-G Pagilla. It's our database -F for file. That's a file flag. And then the name of file, which is actornames.sql. I'll run that. And that's the results. So you'll do that for basically all 9 of these. You'll follow that same approach. When we do the Q&A, what we'll probably do is I'll have each of you do like at least 3 of these. I think Han will be back by then with his internet issues. So I'll probably have you each do three, and we'll just like I might maybe we'll just alternate. Actually, because we're gonna do, I'll have you do screen sharing, so we might do batches of three, so we're not having to jump back and forth with screen sharing all over the place. When we do, kind of like when we have like screen sharing or whatnot, it's totally up to you and your comfort level. If you want to just say like, okay, here's the code right here. I might talk through it, explain what it does. That's awesome. Maybe for you, you're kind of like, okay, I want some more practice of like coding and typing. You don't necessarily like have to do that. Like in your dev job, when you're doing demos, you're not coding and typing unless you're like creating a YouTube video. When you're in front of a team, you're not coding and typing. But maybe you want to do that. Maybe you want to say you want to, comment your solution out down below and then talk through it as you're sharing with the group. So whatever you feel comfortable with, take that approach. Sweet. So we'll continue to work on that through lunch, and then we'll come back, and after lunch, you'll have like a good chunk of time to work on this. Schedule-wise, we're at a pretty good spot. I would love to get to a good chunk of SQL mutations. As much as we can get ahead of the better, because I will say the last 2 days of a React are more than 2 days worth of work. So we already got a buffer day by dropping these data structures. If we can like move fast and get an extra buffer day in so that we can have 3 to 4 days to cover this stuff, I think you all appreciate it and be happy that we kind of bolted through stuff. So yeah, any questions before I let you go? Sweet. All right, well, dive in and reach out if anything comes up. Cool. All right. Yeah, in our Q&A here, we're going to go ahead and we're going to walk through the 9 different little mini challenges. Yeah, there we go. SQL select. These 9 little mini challenges, and I'm gonna let you all kind of do a walkthrough as I mentioned in Slack. So Trey, you'll do problems 2 through 4. Ahmed, problems 5 through 7, and Han, you'll do problems 8 and 9. And so just to kind of demo, you don't have to worry about being like too precise or like just we're just working on our general communication. So like the way I would probably, if it was my turn and I had actor names, um, make that a little bit nicer. I would say basically, okay, so we're gonna get the actor ID, first name, and last name of all actors. If you want to, you could open up PG Web and say like, okay, here's actors, and you can show how there's a first name and last name columns and an actor ID. So you could point that out if that's something that's like quick and easy to do. It doesn't hurt to do. Maybe you just do it for one of them. Because ideally we are grabbing from a table that has columns. So that's research that you would have done. So then you just go to your code and you can live code this if you want. You might have it commented out down below. You can live code it. You can have your code just sitting there. And I'd say, on line 1, I'm selecting the actor ID, first name, and last name column from on line 2 from the actors table. And then just execute the code and just show it in the terminal so we can see that in fact lines up with what we want to do. Actor ID, first name, and last name. And you don't really have to like scroll to the end or anything like that, as long as it looks like it syncs up with what the problem is asking. So yeah, let's kick off with Trey and problems 2 through 4. I'll go ahead and stop my share.
Can you okay?
Yeah.
All right, sorry. So on number 2, it is the actor 40 sequel. So we're to get all columns from the actor with the actor ID. So in the actors table, we look at we can see Oh, well, that is column, sorry. And then in the SQL over here, I have select all from the actors table where the actor ID is equal to 40. And then did you want us to run it?
Yeah, if you wouldn't mind. That'd be
Okay.
great.
Yeah, sorry.
Oh, no worries.
Um,
I should have dropped that in Slack just to
and so when I run it, I get um, actor ID of 40 is Johnny, first name, and last name is Cage.
awesome. Cool. All right, let's do two
Uh,
Kilmers.
and then on two Kilmers, I selected the actor ID and the first name from the actors table
Mhm.
where the last name is equal to Kilmer, and we limit it to only two. And when I run that, we get the actor ID 23 with first name of Sandra, and then the actor ID 45 with the first name of Reese.
Cool. And then if you wouldn't mind, on line 3, could you change Kilmer to double quotes? It's going to be an error, but I just wanted to kind of take a look at what the terminal tells us when we try to do something like this. So let's run that in the terminal. Yeah, and notice that it doesn't give us, it doesn't say necessarily that a syntax error occurs, but that the error is that Kilmore column doesn't exist. So that would be kind of like your clue. If y'all did make a mistake where you accidentally did like a double quotes, you would see that word column right there, and that would tip you off like, oh, okay, I must have put double quotes around a text value when I need to make that single quotes. Yeah, so you can go ahead and revert that.
All right. And then for my third one, select all from the genre table. And I don't remember, but it's probably going to be a huge. Oh, no. So there's only 16 rows
Yeah, it's a
that
smaller
match
table.
that.
Yeah, awesome, cool. Anyone have any questions for Trey or I about uh challenges 1 through 3 or through 4?
Trey, how did you get the? I see the background. You open a database page, the purple one. How did you get
Yes.
that page?
So I opened up a second terminal right here and then ran PG Web inside of that. And you get the, let me come up here to it. Sorry.
Oh,
You
P.
get the
Oh, okay.
HTTP address right there. I
Oh,
just copied it into a browser page here.
okay, okay. Thank you, thank you. That's very
And I
helpful.
just did that so I could see the different tables and what the columns were, the attributes were for me to select from.
Okay, got it. Got it. Let me try. Thank you.
Yeah, awesome. And that's in I think we touch on that a little bit in the Postgres database exercise, Han. You can check out the documentation there. So Postgres database has a little section on PG Web for that GUI that we can use.
Oh yeah, I must have missed it.
Oh yeah, no worries. No worries. All right, Ahmed, you are up with next few problems 5 through 7.
Okay, so I'll share my screen. Can you see my screen?
Yeah, looks good. Yeah.
Okay. So for the second store customers, let me pull up the problem and see what it was asking. So I wanted the email of all the customers that are registered at the DVD store with a store ID of 2. So I did select, and then I did the email column uh, from the customers table, and then I did. Let me pull it up here. So we have the customers table, and so what I did was select the email column from this table, where the store ID column is equal to 2. And then here's what that would look like. So it returned a list, or it returned the email of all the customers uh, with a store ID of 2.
Awesome. Very cool. All right, let's move on to the next one.
All right.
20
And then for
films.
20 films of '06. So it wanted the title, description, and the release year uh, of 20 films released in 2006. So I did select, and then I selected the columns title, description, and release year from the films table. So it's probably gonna crash here. It's always been doing it. Oh, yeah.
Oh yeah, if you I think you close down PG Web in the terminal.
Oh, okay. So I have to.
Yeah, if you can open up like that little double pane and that way you can have the two of them running side by side
Okay.
over by the trash can. Yeah, you can just have PG Web running there. That way it's always going.
So for the films table, I selected these columns, and then I limited it to 20 since it only wanted 20 of them. And then when I run it here in the terminal, that's a little messy.
Yeah,
It returns a list of 20.
what's interesting is could you go back to PG Web?
Yep.
Um, are all of the movies
Yeah.
2006?
All of them are
Oh, okay.
2006.
I was
Yeah.
gonna say you probably wanted to have like some sort of where command release year equals 2006. That's
Right.
interesting that we should probably have a little variety in that sample data to
Well,
make that
actually, it
have
says
some
there's
other
a
years.
thousand of them. I'm not sure if like all 1,000 came out in 2006,
Okay. Huh.
but I guess like I could have also added year or release year as
Yeah, I
2000.
probably after films, I would have done where release year equals 2006. Because then if the idea is that if someone was updating that films database with newer or older films than 2006, you'd already have that kind of built into the system.
Right.
And one thing, just a small note that you can do is like where you have 2006 in quotes. That's fine. That should work. When you are dealing with numbers, I believe you can leave the quotes off and you'd be
Okay.
just fine. So just there's a little flexibility in how Postgres handles that, which in other SQL um, databases might be using might be more particular, but this one we can get away with either or. Um,
Got it.
Sweet, awesome. All right, let's next one, R-rated films.
Okay. So this one wanted the film ID, title, description, and the length of all films, of all rated R films. So I did the select of the films table. Yep, same one. Uh, and then I selected the film ID, title, description, and length columns. And then I added where rating is equal to R. And then that should return. can just get rid of this one. Then I returned 195 rows where ratings are.
Cool. Awesome. Yeah, and this isn't your bad, but I would imagine that our select might have like also wanted to grab the column for rating just so we can see at the output that the rating is in fact R just to do a double check. But no, I mean there's nothing wrong on your end. Um, Sweet, cool. Looks good. Anyone have any questions for Ahmed or myself about those few exercises we just looked at? All right. Well then, Han, you're up to close us out with exercises 8 and 9.
Can you see my screen okay? Oh wait, requesting bypass system. I guess able to see my screen.
Yeah, yeah, looks good.
Um, number eight. So number eight, I need to get 10 film where the highest replacement cost. So so I will need mm, to sort the table with the descendant order and get the first 10. That's basic idea. So I got select film ID, title, replacement cost from films table, order by replacement cost in descendant order, and limit to 10. And to run that. Oh, uh, uh, I was fixing some
Uh,
error.
yeah.
And this is what I got.
There you
So
go.
expensive. And second one, cheap to rent. Get a film ID and title of 50 films that cost less than $1 to rent. Um, cheap to rent. So I select film ID and title from films table, where the rent rate is less than one, and I limit it to 50. And that is that's the result.
Yeah, awesome. And then I think as you can all see, like even though the instructions tell us that SQL queries always have to end in a semicolon, in this environment, we're able to kind of get away with that. Um, so just something to be mindful is that the dev environment can be a little bit different in how finicky it is over things. Probably as like a general good practice, though, I would end all the SQL queries with the semicolon, just to kind of play it safe. Um, yeah, awesome. Well done. Anyone have any questions for myself or Han about challenges 8 and 9? Sweet. Very cool. Well then, yeah, I'll go ahead and do a quick screen share. So I'll take that back over. And yeah, I know this one is still a work in progress for y'all, finish up the quiz questions. So we're not going to jump into the quiz questions right now, so I'm not going to throw you all on the spot. Um, I will, however, drop the quote unquote teacher solution for the quiz questions in the off-topic channel. So as you go through them, you can kind of compare what you had with kind of like the official solution. So really quick, what I do want to do is I want to move us before break time to the SQL mutations exercise that was released. And SQL mutations is basically the rest of the CRUD operations, right? That's where you're mutating the database. The select that we just did, the read operation is just reading from a database, right? We're not changing the database at all. So mutations of inserting in data, updating data, deleting data, we are in fact doing something to the database at that point. So that's why the name mutations kind of encapsulates those statements. So there'll be some quiz questions. Uh, our goal, mentioned a few times, is we are trying to establish CRUD functionality with our SQL queries. So we've covered the read functionality of CRUD with select command. And then in this exercise, we're gonna cover the create functionality of a SQL query with the insert command, the update functionality of an SQL query with the update command, and then delete functionality with the delete command. So they line up somewhat similar in a few of the names. You'll just have to remember that select is read and insert is create. So just like most of the exercises we'll be kind of going through, you're always going to want to make sure, check your status of Postgres is up and running. If it's not, go ahead and start it up. And then this exercise, just like the previous exercise, you're going to be running this in the terminal, and you'll just run the name of the file. So psql-g-d pagilla-f for a file, and then the name of the file. There are a few tips of how you can like list the databases in the terminal. And this is just recapping of what we've done earlier. However, I've found usually the easiest approach is just to have the PG web open. I feel like that's a lot easier to read the data than reading in the terminal. So that's my high preference. But if you just like to knock stuff out in the terminal to look at it, that's totally fine if that's what feels good for you. You may get into a situation where you need to just like reset your database. There's not too many scenarios that I would see you getting into that situation. But if you did, if you inserted something in there, or you updated something, or you deleted something for some reason that you really didn't want to do, then you can restore the database. You'll do that by dropping the database, recreating it, and then running those seed commands to bring in the schema again, and then bring in all the seed data. So it's just 4 commands that you would do, and you get back to that refreshed state of what your database originally was. So now it's a little bit of pre-reading, and then you'll get into the first mutation we're going to work on, which is the insert. So that's going to be the create functionality. That'll open up a new tab for you. And then we're basically going to have a page devoted to each one to insert, update, and delete. So for SQL insert, there's going to be a little, documentation area. The insert statement is a means of adding rows to a table, creating. And so we have this products table that we can imagine right here. It's got a product ID column, name, description, price, and category column. And so if we want to add a row to this table, we would do something like this. Insert into, that's the command. That's how we insert. Remember, lowercase, uppercase doesn't matter. Just be consistent. The team you're on will have a strong preference when you join that team. But for now, just be consistent. And so we're going to insert into products, because that's the name of our table. And this is where it's a little bit different. We're not going to just name the columns. We will name the columns, but they need to be inside of parentheses. And then you name the columns. You could put them in any order, but their order will matter later when you do try to insert values. So into products, we want to insert into the name, description, price, and category column. What do we want to insert? We use the values command. And then we have to have these parentheses right here. And we're going to insert ostrich pillow. And this is where the order matters. Ostrich pillow is because it's the first value. It's going to go into the column that is listed first. Feeling comfy and cozy is going to go into the next column that was mentioned, description. 99 will go into the third column that was mentioned, price. And then self-care will go into the last column. So just keep in mind that you could write the columns in any order in the beginning, but when you go to insert values, they need to line up with whatever order the columns are. The other thing to note is that when we did the select the read functionality, it always spit data back out to us, right? Because that's what select is. It's read functionality, so we always got data back. However, when you use these mutation commands, they're just going to update the database. They're not going to naturally give you back information. You'd have to do another select after that to see what you did. So just down below that, I jumped ahead a second. Down below that, if you were then to like read from products, you would see that, okay, you added your thing in. There's some more detailed explanation of the syntax up above. And this is getting back to where what I just talked about is that insert into isn't read functionality. So what you can do is instead of having to do this afterwards to confirm that you added something at the very end, you can simply do your insert into, your table, your columns, these values, and then at the end you do returning asterisk. And what that will do is that will return to you those columns and those values that were inputted into the column. So you can see what you created. Then there's more documentation on multiple rows, some more thoughts on this returning clause that I just talked about. And then you're going to have two exercises that have to do with inserting into. So you'll knock out those two. And then when you're done with those, you'll move on to SQL update. Again, documentation. Then you got 3 questions, and then you'll move on to delete. Again, documentation, and then 4 questions. So a little bit, exercises grow a little bit more as we get a little further into it. So that's what we have for us to do. So, at 3:30, we're going to go into break. That's 4, 5, 6, 7. That's another 9 challenges there. So we're not going to be able to get into a Q&A before the day is over. My hope is that we would be able to start tomorrow morning with a Q&A on this exercise. So getting as much done as you can by 5 to kind of like limit your homework would be awesome. And I know I'm repeating myself, but like the faster we can chug through this stuff will be really important because the last couple of days of React next week take more than 2 days. So if we can stretch that into at least 3 days, maybe 3.5 days, I think we'll really be happy with that pacing. So yeah, any thoughts or questions before let you all dive in and get started on mutations? Yeah. Sweet. Sounds good. Well, yeah, 3:30 break. I'll be here through 5 o'clock. I don't see a need for an end of the day meeting, but I'll be here through 5. So ask me any questions. You want to jump into breakout room, chat. Totally around, totally here to help. And if not, we'll all meet back up tomorrow at 9 to go over this in our Q&A. So we'll talk to you in a bit.